this lecture, we will be talking about data models. After completing this chapter, you will be able to discuss data modeling and why data models are important, describe the basic data modeling building blocks, define what business rules are and how they influence database design, understand how the major data models evolve, list emerging alternative data models and the needs they fulfill, and explain how data models can be classified by their level of abstraction. Models are an abstraction of a more complex real-world object or event. Take for example, if you are building a house, before you build the house, you have architects drawing the blueprints that will be followed in developing the house or building the house. Same goes in developing our database. We need to have a data model that will be a representation of the complex real-world data structures that we're going to implement in our database. Now, why are data models important? First, it facilitates communication between the clients and us, the designers of the database. Also gives various views of the database and how it is going to be seen by the end users, by the database designer, and by application programmers, for example. Also organizes data for various users. Our database, usually they cater to multiple users. So having a data model gives us a way to organize our data for their various uses. And lastly, it provides an abstraction for the creation of a good database. In anything that we are implementing, it is always better to have a good design before we implement things. And same goes with implementing database. We need to have a data model first. Let us now familiarize ourselves with the basic building blocks of data models. First, we have entities. Entities are persons, place, thing, or events about which data will be collected and stored. Attribute, these are the characteristics of an entity. Relationships, these are the association among the entities. It can be one-to-many, many-to-many, or one-to-one. We will be discussing more about this later. And constraint, these are some restrictions that we might be placing on our data. And the constraints are the ones we are using to ensure that we have data integrity. For example, if you're going to create a data model for the student enrollment, example entities could be student and let's say subjects. Attribute, these are things that we are collecting about those entities. So for students, we might be collecting first name, last name, student number, age, among others as attributes. Relationships, these represent how the two entities or two or more entities are associated with each other. So in this case, if our entities are student and subjects, a student can take many subjects and a subject can be taken by many students. So we have a many-to-many relationship. And constraints, like for example, we can put constraint on, let's say, having a prerequisite course. So they should have a grade of passing first in a prerequisite course before they can enroll in a subject, among others. We will have more discussion and examples of the data model basic building blocks as we go along our discussion. Now let us talk about business rules. Business rules are brief, precise, and unambiguous description of a policy, procedure, or principle. They create and enforce actions within that organization's environment, and we are using these business rules to establish our entities, the relationships of the entities, and the constraints that we are going to implement in our data models. So when we are creating a data model, we are making use of the business rules as a guide in establishing the entities, relationships, and constraints. Now, where do we get business rules? We can get business rules from interviewing company managers, department managers, policymakers, or direct interviews with the end users or people who are going to use of our database, or even written documentations like policy manuals and employee handbooks. So why do we need to identify and document business rules first? First, they facilitate communication between users and designers. Since we are creating a database for the users, it is important that we have a tool that we can use to communicate with our users. Next is standardize. So we need to have a standard view of data of the company. As we all know, if we have different departments in a company, they might have different ways on how they are handling data that are the same for that should be the same. So it is important that we identify the business rules so that we would have a standardized view of the data company-wide. And lastly, assist. Having the business rules assist the designers in understanding the nature, the role, the scope of data, and the business processes. Also assist the designers in developing appropriate relationship participation rules and constraints, and in creating an accurate data model. As we have said earlier, we are using business rules to establish our entities, constraints, and relationships. So the business rules set the stage for the proper identification of whatever entities, attributes, relationships, or constraints we may have. If you have business rules, the nouns that you have in the business rules translate into entities, and the verbs translate into relationships among the entities. Take note when you talk about relationships, they are bidirectional. So when we talk about relationships, we need to ask these two questions. How many instances of entity B are related to one instance of entity A? And how many instances of entity A are related to one instance of entity B? So when you say bidirectional, we need to take into consideration the perspective of one entity going to the other entity. And through that, we are going to be able to establish what kind of relationship those two entities have. May it be one-to-one, one-to-many, or many-to-many. Let's now talk about the naming conventions. For entity name, it should be descriptive of the objects in the business environment. We need to make use of the terminology that is familiar to the users. So for example, if our entity is about employees, we can use the employee as our entity name and refrain from using ambiguous entity names like entity 1, entity 2, among others. For the attribute name, it is required to be descriptive of the data represented by the attribute. And why do we need to have these naming conventions? First, it facilitates communication between the parties, and it promotes self-documentation. If we are using the names as the names of our entities, then there really is no need for us to explain what the entities are all about. Once the user see the entity names, they know exactly what those represent in the business environment. Now let's talk about the different data models. First, hierarchical model. The hierarchical data model is a data model in which the data are organized into a tree-like structure, just like what we can see in the following example. The data are stored as records, which are connected to one another through links. And in this case, a record is a collection of fields, with each field containing only one value. In this particular example, we have a tree-like structure of the records for the employees of certain branches of a bank. So as you can see, for each of the branch, like branch 005 for London, you can see that the connection that it has to the employees represent those employees that belong to that branch. The hierarchical data model was developed to manage large amounts of data for complex manufacturing projects. It is represented by an upside-down tree which contains segments. Those segments are the equivalent of a file system's record type, and they depict a set of one-to-many relationships. In the example earlier, the one part would be the branches, and the many part would be the employees. The following are the advantages of hierarchical model. First, it promotes data sharing and they are easy to understand. Since we are creating a model out of our database, then we would know that the model that we have is targeted towards promoting the data sharing and for simplicity's sake. Next, we have a parent-to-child relationship, which promotes conceptual simplicity and data integrity. Also, database security is provided and enforced by the DBMS that uses the hierarchical model. And lastly, it is efficient with one-to-many relationships, particularly because the hierarchical model is designed for such relationships. For the disadvantages, it requires knowledge of physical data storage characteristics. We also have navigational system, which requires us to have prior knowledge of the hierarchical path. Like in our previous example, before we can go to the employee record, we should know which bank branch that employee belongs to first. Next, changes in structure require changes in all application programs. So if your database is using hierarchical model and there are some change in the structure, then you would have to change everything else and start from scratch. Then the implementation limitations, it is very expensive to implement the hierarchical model. We also have no data definition and there is a lack of standards, as this is one of the first data models that were introduced in the early early days.